India, with its vast landscapes, holds hidden within its territory a powerful natural force: volcanoes. While the snow-capped Himalayas might first come to mind, two less conspicuous islands off the Indian coast demand attention: Barren Island and Baratang Island. These islands, seemingly tranquil, are reminders of the Earth's fiery underbelly. Located in the Andaman Sea, their existence hints at the powerful tectonic forces at play beneath the Indian Ocean. Barren Island, true to its name, stands as a stark reminder of nature's raw power. It is India's only confirmed active volcano, a smouldering cone rising out of the turquoise waters. Baratang Island, on the other hand, presents a different face, one veiled in lush greenery. Beneath this serene exterior, however, lies a network of mud volcanoes, bubbling and spewing mud, a testament to the restless earth below. These islands, though geographically separated, are linked by a common thread. They owe their existence to the Indian tectonic plate's relentless journey northward. This slow but unstoppable movement, pushing against the Eurasian plate, has shaped the landscape we see today, creating both majestic mountains and these fiery islands. Understanding these islands is not just a matter of scientific curiosity. It is a matter of understanding the forces that shape our world and the potential risks they pose. The birth of Barren and Baratang Islands can be traced back millions of years to the depths of the Andaman Sea. Here, at the junction of the Indian and Eurasian tectonic plates, lies a zone of intense geological activity, the Sunda subduction zone. The Indian plate, relentless in its northward journey, plunges beneath the Eurasian plate, creating a maelstrom of heat and pressure. This process, known as subduction, is the engine that drives the volcanism in the region. As the Indian plate sinks deeper into the Earth's mantle, temperatures and pressures soar. The intense heat melts the rocks of the descending plate, creating molten rock known as magma. This magma, lighter than the surrounding rocks, rises buoyantly towards the surface, seeking an escape route. When it finds one, it bursts forth as a volcanic eruption, building over millennia the islands we see today. The contrasting features of Barren and Baratang, however, reveal the diversity of volcanic activity. Barren Island, a classic cone-shaped stratovolcano, is forged from layers of solidified lava and ash, a testament to centuries of explosive eruptions. Baratang, on the other hand, showcases a different face of volcanism: mud volcanoes. These smaller, less violent features are formed by the expulsion of mud, gases, and water, often heated by the magma below. While less dramatic than their fiery counterparts, mud volcanoes serve as a constant reminder of the geothermal forces at play beneath the surface. Barren Island, the most active volcano in the region, has a history as fiery as its appearance. The first recorded eruption dates back to 1787, marking the beginning of a period of intermittent activity that continues to this day. Over the centuries, numerous eruptions have punctuated the island's history, transforming the landscape with each fiery outburst. Clouds of ash, rivers of molten lava, and the occasional explosive burst have left their mark, shaping the island we see today. Baratang Island's volcanic history, though less documented, is no less intriguing. While the island itself is not a volcano in the traditional sense, it hosts a cluster of mud volcanoes, each a window into the Earth's fiery depths. These mud volcanoes, prone to periods of dormancy punctuated by sudden eruptions, have sculpted the island's landscape with their muddy flows. In 2005, a particularly dramatic eruption spewed mud and debris high into the air, a stark reminder of the volatile forces hidden beneath the surface. These past eruptions, though varying in intensity, provide valuable insights into the behavior of these volcanic systems. They serve as a stark reminder that these islands, though seemingly tranquil for long periods, can awaken with little warning, unleashing their fury upon the surrounding environment. Studying these past events is crucial for understanding the potential risks posed by future eruptions and for developing effective mitigation strategies. While past eruptions offer a glimpse into the destructive potential of Barren and Baratang, What keeps volcanologists awake at night is the spectre of a maximum eruption, a worst-case scenario that could have devastating consequences for the region. While the probability of such an event might be low, the potential impact is significant enough to warrant serious consideration. A maximum eruption from Barren Island, for instance, could unleash a catastrophic chain of events. The eruption itself would be cataclysmic, spewing colossal volumes of ash, rock fragments, and volcanic gases high into the atmosphere. This ash cloud, carried by winds, could spread far and wide, blanketing nearby islands and potentially disrupting air travel over a vast area. However, the most immediate threat would come from pyroclastic flows, superheated avalanches of gas and volcanic debris that race down the volcano's slopes at hurricane speeds, incinerating everything in their path. These flows, capable of travelling across water, could pose a significant threat to nearby islands and any ships unfortunate enough to be in their path. Additionally, the eruption could trigger tsunamis, giant waves that could devastate coastal communities along the Bay of Bengal. Baratang's mud volcanoes, though less immediately destructive, could still pose significant risks in a maximum eruption scenario. Large-scale mud flows could inundate surrounding areas, destroying infrastructure and potentially causing widespread ecological damage. The release of methane and other gases could also pose health risks to local populations. Section 5. Learning from global catastrophes. To fully grasp the potential threat posed by Barren and Baratang, it is essential to place them within the context of historical volcanic eruptions that have shaped our world. While neither island has experienced an eruption on the scale of, say, Krakatoa in 1883 or Mount Tambora in 1815, these historical events serve as stark reminders of the immense power that lies dormant within volcanoes. Krakatoa's eruption, one of the most powerful volcanic explosions in recorded history, unleashed tsunamis that killed tens of thousands of people across the Indonesian archipelago. The eruption plunged the region into darkness, and the sound of the explosion was heard thousands of kilometers away. The eruption of Mount Tambora, even more powerful than Krakatoa, ejected such vast quantities of ash and sulfur dioxide into the atmosphere that it triggered a volcanic winter the following year, causing widespread crop failures and famine across the globe. While the probability of Barren Island or Baratang Island producing eruptions of this magnitude is low, it is not impossible. The geological context in which these volcanoes exist is similar to regions that have experienced such catastrophic events in the past. Therefore, it is crucial to learn from these historical tragedies, to understand the potential scale of the threat, and to prepare accordingly. The relative inactivity of Barren Island in recent years, coupled with the less dramatic nature of mud volcanoes, might lull some into a false sense of security. However, it is precisely during these periods of quiescence that vigilance is most crucial. Volcanoes are notoriously unpredictable, and eruptions can occur with little to no warning. The seemingly benign nature of mud volcanoes can be particularly deceptive. While their eruptions are often less violent than those of their magmatic counterparts, they can still be destructive and disruptive. Furthermore, the release of methane and other gases from mud volcanoes can pose health risks and contribute to climate change. The lack of recent large-scale eruptions in the Andaman region should not be misinterpreted as an indication of future behaviour. Instead, it should serve as a call for increased monitoring and preparedness efforts. The longer the period of quiescence, the greater the potential energy that could be released in a future eruption. Therefore, it is vital to remain vigilant and to invest in the scientific infrastructure needed to monitor these volcanoes effectively. In light of the potential threat posed by Barren and Baratang, continuous monitoring is essential. Scientists employ a range of sophisticated tools and techniques to keep a watchful eye on these volcanic islands, striving to detect any signs of unrest that might precede an eruption. Seismographs, deployed strategically around the islands, listen for the telltale tremors that often accompany the movement of magma within the Earth's crust. These subtle vibrations, imperceptible to humans, can provide valuable clues about the state of activity within the volcanic system. Similarly, GPS stations track minute movements of the Earth's surface, deformations that can indicate the buildup of pressure within the volcano, a potential precursor to an eruption. Gas emissions, another crucial indicator of volcanic activity, are also closely monitored. Changes in the composition or volume of gases released from volcanic vents can signal shifts in the magmatic system below, providing valuable insights into the potential for future eruptions. Regular aerial surveys and satellite imagery complement these ground-based monitoring efforts, capturing changes in the volcano's shape, temperature, and gas emissions from above. This multifaceted approach to volcano monitoring is crucial for providing timely warnings of potential eruptions. By combining data from various sources, scientists can gain a more comprehensive understanding of the volcanic system's behavior and improve their ability to forecast future events. While monitoring is essential for providing early warning of volcanic unrest, effective disaster preparedness measures are crucial for minimizing the potential impact of an eruption. Given the unique challenges posed by volcanic islands, a multi-pronged approach is essential, encompassing community education, evacuation planning, and infrastructure development. Raising awareness among local populations about volcanic hazards is paramount. Educating communities about the signs of an impending eruption, safe evacuation routes, and emergency procedures can save lives. Regular drills simulating a volcanic eruption can help instill a sense of preparedness and ensure that residents know how to react in a crisis. Developing robust evacuation plans is equally crucial. In the event of an eruption, swift and efficient evacuation of vulnerable populations from nearby islands will be essential. This requires identifying safe havens, establishing clear evacuation routes, and ensuring the availability of transportation and logistical support. Investing in infrastructure that can withstand volcanic hazards is also vital. This includes designing buildings that can resist ashfall, protecting critical infrastructure from mudflows and tsunamis, and ensuring the availability of alternative energy sources in the event of an eruption. Barren Island and Baratang Island, with their fiery temperament, stand as a stark reminder of the awesome power of nature. While they pose a potential threat, they also offer valuable lessons in resilience and adaptation. Living in the shadow of volcanoes requires a delicate balance between respecting their power and harnessing the benefits they offer. The fertile volcanic soils of these islands, enriched by volcanic ash, support unique ecosystems and provide livelihoods for local communities. The geothermal energy potential of these islands, if harnessed responsibly, could provide a sustainable source of energy for the region. Ultimately, living in harmony with these volcanic islands necessitates a deep understanding of their behavior, a commitment to preparedness, and a healthy respect for the forces that shape our planet. By embracing these principles, we can strive to mitigate the risks, harness the benefits, and coexist peacefully with these awe-inspiring forces of nature.